In this pod, we're going to continue our study of solving literal equations. The literal equations we solve will all be linear, and so we will still be using the same 5 steps for solving linear equations that we started a couple of podcasts ago. Step 1, eliminate fractions. Multiply every term by the common denominator. Step 2, get the objective variable, which later I'll call x, but get the objective variable out of the grouping symbol by distributing. Step 3, get your x terms to one side and your non-x terms to the other. Step 4, form your x terms into a single x term. And step 5, reverse what's done to x. Okay, in this particular problem, our objective variable is not called x, it's called n. But it is an equation with fractions, so the first thing we need to do is locate the common denominator. Your common denominator will never be smaller than your biggest denominator. So the first thing we'd want to try is 8. If the other denominators will divide it, then that's our common denominator. Well, 4 divides it and 2 divides it, so 8 is the common denominator. And I'll multiply that by every term. Times 8, times 8, times 8. Now notice even the term 2, which doesn't even have a fraction on it, still gets multiplied by 8. You got to emphasize the every term. Multiply every term by the common denominator, whether it's a fraction or not. Okay, in the first term, the 8's cancel. I'm left with 3n. In the second term, the 4 cancels the 4 but leaves a 2. So I'm left with 2 times 3, which is 6. In the third one, the 2 cancels the 2, leaving a 4. So I'm left with 4 times n minus 4. Now you may wonder where that bracket comes from on the n minus 4. Well, that's a horizontal division line. And as we said below, every horizontal division line has a bracket above it and a bracket below it. Once we cancel the 2, the horizontal division line goes away. So we can't leave that bracket invisible anymore. Since the division line's gone, you've got to show that bracket. And then for your last term, 8 times 2 is 16. Step 2, get the objective variable out of the grouping symbol. Well, in our problem, n is in a grouping symbol, so we'll distribute to get it out of there. 3n minus 6 is equal to, and we'll distribute to each term. And there's 2 terms in the bracket, so 4n minus 16. And then the last term plus 16. Well, that worked out well. The minus 16 and the plus 16 zero each other out. Next step, get all your x terms to one side. Right now they're on 2 sides. When I'm deciding which x term to keep and which one to get rid of, I always get rid of the littlest term. Here the 3n is smaller than the 4n. So I'm going to say get rid of 3n, take away 3n, and do that on both sides. And so I get negative 6 on the left and 4n, whoops, that's supposed to be an n there. 4n minus 3n is n, and that's the end of the problem. N equals negative 6. In the second problem, we not only have fractions, but variables occur in the denominator. In fact, this is a solve for r. The objective variable is in the denominator, so let's see how we handle that. Since there are fractions, we're still going to have to get a common denominator and multiply the common denominator to every term. So let's think about our common denominator in 2 different pieces. What's the number part? Well, the biggest number denominator is 6. The 3 divides it, the 2 divides it, so the number part of the common denominator is 6. But the denominator also has letters, but it only has one letter, r. So the letter part of the common denominator is r. So I want to multiply every term by 6r. So times 6r, times 6r, times 6r, and times 6r. And in the first term, the r cancels the r. The 2 cancels the 2 and leaves a 3. So all I have left from the first term is 3. Now the second term has no denominator. We still have to multiply it by 6r. But since there's no denominator, there's no canceling. and so we get minus 18r. In the third term, the 3 cancels a 3 in the 6, leaving a 2, and the r cancels the r. So I'm just left with 2 times 2, kind of getting crowded here, or 4. And then in my last term, the 6 cancels the 6, so I get plus r. Didn't mean to jam them together that way, but I think we can keep things straight. Now, as we go on to step 3, again we want our r terms on one side and our non-r terms on the other side. But which is the small r? The positive 1r or the negative 18r? Well, to me, negatives are always smaller than positives. So what I'm going to do is add 18r. Now, if you want to subtract r from both sides, that's okay. Just do it correctly. This is just my personal preference. So I get 3 plus 0, which is 3, is equal to 4 minus 17r. And that gets my r terms to one side. Now I need to get my non-r terms to the other side. So I'm going to subtract 4. And I get negative 1 is equal to negative 17r. Step 5, reverse what's done to r. Now r is multiplied by negative 17. So if you want to reverse what's done to r, you've got to divide it by exactly negative 17, not just 17. So I'll divide both sides by negative 17. The negative 17's cancel. Negative over negative gives me positive, so I end up with r equals 1/17. Now the third one starts to get fancier. More variables, more variable denominators. This time the common denominator might leave you a bit confused. But let's take a look at it. Again, go to your biggest denominator. GR you can think of as being bigger than G because it contains the G. And is the GR divisible by G? Well, if I put GR over G, the canceling shows me that G goes into GR r times. So G really does divide GR, so GR is our common denominator. So I need to multiply it by every term. GRZ is equal to GR times 1 plus G over G. That's not a very good G. 1 plus G over G. And then GR minus GR times the last term, JX over GR. Well, the canceling in the last term is pretty obvious. The GR cancels the GR, so I get minus JX. How about the first term? Well, there's nothing to cancel here. Canceling is done top to bottom, so I just get GRZ is equal to. Middle term, the G cancels the G, and I end up with R times 1 plus G. Now, here comes a critical point. Do I distribute the R? Because that's normally what you do when you're solving. Well, step 2 doesn't say to just distribute anything. It says get the objective variable out of the grouping symbol. Notice we're solving for R, and R is not in the grouping symbol. So I don't have to get R out of the grouping symbol. I can skip the distributing here and just move on to step 3. Step 3 says get all your R terms on one side and all your non-R terms on the other. Well, let's see here. I've got 2 R terms, and right now they're on different sides. And I'm going to have to make significant moves no matter what. So here's what I'm going to do. I'm going to move the GRZ term to the right. That'll leave this big term with the bracket kind of cleared by itself, and I won't have to move it. And then I'll move the JX to the left, and that's going to put a positive on the JX. So let me show you how that works. To move the GRZ to the right, I go minus GRZ and then minus GRZ. To move the JX term to the left, I go plus JX plus JX. So now, what's left on the left? Well, the positive GRZ and the negative GRZ zero each other out. So all that's on the left is JX. On the right, I have R times 1 plus G minus GRZ. And now I have completed step 3, get my R terms on one side, both R terms are on the right, and my non-R term is on the left. But now it gets difficult. Step 4 says form all this mess here on the right into a single R term by factoring out R. So right now I've got two terms. My two terms are separated by that minus. And I'm going to factor out R. So what's going to be left? Well, something has to go here that gives me R times 1 plus G. So here I'm going to put 1 plus G. And something has to go here that'll give me negative GRZ, and I'm going to be multiplying by R, so I want negative GZ. And that's equal to JX. Now can I simplify if I distribute and get this 1 plus G out of the grouping symbol? Not really. I can kind of get rid of the grouping symbol. I guess that's a little bit of a simplification. But I can't combine the G with the GZ. So I'll go ahead and I'll distribute this out. There's a 1 right here. And just to get rid of the bracket, I'll say 1 times 1 is 1. 1 times G is G minus GZ. I've kind of cleared that out. And now we're to step 5, reverse what's done to R. R is multiplied by the bracket. To reverse that, divide by the bracket. 1 plus G minus GZ. And over here the brackets cancel. And so that is your final answer. R is equal to JX over 1 plus G minus GZ. Okay, let's take now this exact same problem, and instead of solving for R, which only occurred one time in the equation, let's solve for G. That thing pops up 3 times. Can we get G by itself? So here I have the same problem written up, this time solving for G. We've already decided that the common denominator is GR, so I'll multiply it by every term. GRZ equals to GR times 1 plus G over G minus GR times, and it's this kind of an R, capital R, GR times JX over GR. So again on the last term, the GRs cancel, so I'm left with minus JX. Okay, what about the other terms? Well, on the left, just GRZ. Again, I'm going between small and big R's. I need to stick with the big R there. How about this term? Well, here the G cancels the G. So again, I get R times 1 plus G. Now remember that last time we were solving for R. R was not on the grouping symbol, in the grouping symbol, so we did not distribute. Now this time our objective variable is G, and G is in the grouping symbol. So this time we do have to get G out of the grouping symbol by distributing, so that's going to be a difference between this problem and the last one. We get R plus RG minus JX. But everything's fine now. We just want all of our G terms on one side and our non-G terms on the other. I think the easiest way to do this here, because we have to do a lot of moving if we don't do it this way. To get all our G terms on one side, I'm just going to subtract big RG. Like so. And then those two terms will zero each other out. So on this side I will have no G terms. That's plus 0 minus JX. And on this side I'll have two G terms, GRZ minus RG. Step 4 says form a single g term by factoring out g. So I'll put g on the outside. To get the first term, I'll need to multiply g times rz. To get the second term, I'll have to multiply g by negative r. And I didn't do anything on the other side, so that's still r minus jx. And now I'm at step 5, reverse what's done to g. So I'll divide by rz minus r, divide by rz minus r. On this side, the brackets cancel, leaving me g. On this side, there's no g, so I have indeed solved this for g. Cannot reduce it. That is a simplified form, and that completes the podcast.